welcome to this speech. I would like to tell you this story from the field, a story inside our company, but that can have general applicability for the argument of the general quality in the software production in a large industrial software factory. I'm Daniele Gagliardi from engineering group, sorry. And last year I was here to talk about project intelligence. We told you about our CMMi project infrastructure. Oh, okay, sorry. And last year we saw project intelligence made with Spago4Q, with data collected from our engineering CMMi infrastructure for software project. We saw dashboards, reports, and other stuff. Engineering group, I don't want to bore you with several numbers, just to understand the context in which this experience was made. It's a large company with several branches in Italy and abroad. And at the start of this year, a new organization was set in our company. A new organization to have software production more effective. The software factory was separated from the business units. Business units face directly with our worldwide customers. And the business units provide requirements and requests to our software factory. In this slide, there are a lot of details, but the key concept is that we have a software factory that builds software, and the software is then delivered by the business units. Okay. Soon, one need. Our CEO want to know if this reorganization of our company is good. He want to know if this software factory is productive enough. And at the start of this year, he put a question to us. I want to know the productivity of our software factory using function point metric. This is why, because the market reason also only in function point, and so he want to know a number. But the reality is more complex. We have a lot of managers' needs. Here you can see several questions arise from top management, but also quality management and also project management. And each of them have some concerns about the several aspects of the quality, which is users and customers' level of satisfaction. Very important. And we cannot know this aspect on the measuring function point, for example. So the question become more complex. And also, engineering is a compelling constraint about quality standards because it's certified, for example, at CMMi for development at level 3. Okay, the assessment is during these days, and also IT compliance and ISO compliance. The setup of our software factory, the name is ESL, Engineering Software Labs, and I refer to this name to talk about our software factory. Was set up to enhance and measure productivity and improve quality practices. Okay, this is the key question, productivity intelligence. We cannot talk about productivity in terms of one single measure, because productivity is a is a very complex aspect to investigate. We say that productivity intelligence lets quality emerge as a contribution of three main aspects. The social aspects, because people are very important in the production. The economic benefits, obviously. In the slide of our group profile, we saw a lot of number relating to the economic aspect. And also technical properties. We cannot sell something that has poor technical properties to the market. And we found the solution using a model, mathematical model, to describe the feature, the aspects of the productivity, and a tool to implement this model. The model is named QESTnd model. It's a conceptual framework for measuring process performance, and is based on multiple analysis dimensions. It's a general model. It's not a model for engineering group. It's very general. And the tool, Spago4Q, you know it. It's a project of our OW2 consortium. Here you can see some sources of information to evaluate productivity. We have the ESL, the software factory infrastructure, made by ALM tools and project repositories and tools to analyze code quality and so on. But we also have the business unit infrastructure, because they need to track their requirements and their issues and a separate infrastructure. And more often, we have also the customer's infrastructure, because how often customer use its own infrastructure. And all of these infrastructures provide information useful to understand what is the general productivity of the software production. Okay, some words about this QEST model. We talk about three main dimensions of analysis. The QEST based the economic dimension, the social dimension, the technical dimension, and the performance measured for each dimension allow to identify the process areas that need improvements, because this is very important. We cannot improve what we don't know, and we don't know something if we cannot measure it. So this model allows us to gain knowledge of our point of force and weakness. Okay, here we have some detail, but I want to point on the main aspects. QEST as a geometrical representation based on a tetrahedron. Tetrahedron which have three edges. Each edge represents a single dimension, the economic, the social, and the technical dimension. And each edge has values from 0 to 1 to make easy to understand which is the level of that particular dimension. And when we collect metrics that contribute to one single dimension, we obtain a point on each edge. So we can measure, for example, the volume of the part of the tetrahedron. And relating to the overall volume, we can get the number that our CEO asked in a different measure unit. But it's a number that could be drilled down in all the contributions. The main aspects are there at bottom line. We measure project performance using three distinct viewpoints, but not only project performance, the performance of the entire software factory. And the input data are a list of weighted ratios, weighted metrics for each dimension, and quality questionnaires, very important is, because we deal with quantitative data, but also qualitative data. They are difficult to get, but they are very, very important. And the output data is an integrated, normalized value of performance. So we have found this solution. The tool, okay, the tool is Spago4Q, is a vertical of Spago BI focused on quality. In the central part, you can see the ETL component that extract information from all that infrastructures that I showed you in the previous slide. And so we can speak about an integrated environment made by the model and the tool. Okay, the procedure is very interesting because it starts from the cycle of Deming. I don't know if you remember the plan, do, check, act. This is the Deming cycle applied to the identification of metrics and to control the process. So in the plan phase, we define a set of metrics using the goal question metric approach. And we use these metrics to measure our reality. And using this measure, we assess, we can find the weakness and strengths, and so we can improve. We have the knowledge, and so we can improve. If we don't have the knowledge of the weakness, we cannot improve. Okay, some example of main goals for the goal question metrics approach. We define some goals that we want to achieve, and for each dimension, goals for economic, social, and technical dimensions. And then we can define metrics for each single goal. Okay. In this table, you can see on the right the source of our metrics, the formula, an ID, and so on. Very important. We put a special importance on social analysis, because from the social aspect, from the social dimension, we collect quantitative data and qualitative data. Quantitative data are mostly about how people adhere to corporate processes, and qualitative data are obtained submitting line survey questionnaires. Okay, and we use the Net Promoter Score approach. It's known also as the ultimate question, to evaluate the qualitative data coming from the questionnaires. Okay, now some screenshot for the drill down from the performance value, from the single performance value, and to the single components of this performance value. Okay, these are several reports we made, and okay, if you want, you can see this also in our brochure. These are real reports. We use these reports, okay? We did it. So, the case in a nutshell, it's a 3D dimensional analysis on productivity for these three particularly important dimensions. Bear in mind that CAST is a generalizable model, so you can add dimensions. One possible improvement is the risk analysis, that it could be considered an independent dimension. All happy. All happy, all have their answers. We are getting some feedbacks from our internal customer. Now in a formal way, with emails, but soon with line survey questionnaires. And a proposal. This is a very general model, so why not? We can use it to measure and enhance the performance, the productivity of the OW2 consortium. Okay, I'm finished. Thank you.